Welcome back, friends, to this series of Windows thread synchronizations using various techniques. You know that we are discussing about the mutexes. So, in this series, we are moving ahead today with some more examples. So, one of the examples I'm going to take is like there are two applications. One is writing to the database, and the other is reading from the database, and we need to synchronize the access between the two. All right, so there will be two applications. This one, the current application that I'm going to write, this will be this you can consider that it is going to write that it is going to write to the database, and I will create another application that you can consider as that is reading from the database. Okay, so let's do. So here you can see that I have created one mute handle for mutex handle h mutex, and here I have created the mutex. And you know that already I have discussed about these various arguments. First argument is the security descriptor, which we pass null, which means that whatever default security attributes are there, whosoever has logged into this system, whatever applicable to that person, that particular entity, whatever access rights are there, those will be applicable to this application as well. The second argument is which tells like if you are the owner of this particular mutex or not. If you are the owner of the mutex, then, and if you are not the owner of the mutex, then the difference between these two cases I have already explained you in the previous video. Okay, so you can refer to that video, but in this video we are just going to simply create a mutex, and I'm not the owner of this. I'm just checking it in the usual way. I have already told you that you need to check your mutex creation or any kernel object creation in this manner. All right, so this has been created here, and here I'm just releasing it and closing it. So in between these two, I'm just assuming that we are writing something to database. Okay, so if we are writing something to database, then what can be the case? Cout engl press any key when the message comes that db is updated. So if the message comes that database has been updated, then in that case you need to press the key. So for that we are just going to put some sleep here for 20 seconds, or you can say 10 seconds would be enough. Okay, so after that I will simply accept a character, and before that I will just print the message that ngl, and here I will print like db write completed. So this is the way we can do this. So the db write has been completed, and then you will press any key, press enter. Enter key. Okay, so this is my application which is writing to the database. Let me just compile, build, and run it, and then we will create one more application which will be reading from the database. So we are not doing here any database stuff. We are not actually updating anything in the database. I'm just showing you that you can pretend that at this position, at these lines between this sleep, something is happening which is equivalent to updating something in the database. You are just pretending that you are just updating something in the database. Okay, so once you are done, you can just display the message db write completed. Please press any key, press enter key. So let me just run it, and let's see what happens. So here you go, and here you will be able to see the message. Press enter key when the message comes that db is updated. Okay, so now db write has been completed, and it is asking for you to press any key. So it has been pressed and it's done. So we can simply do like here, you can simply reduce the wait to 2 seconds only, or you can say 5 seconds only, right? So this is just a fake code where we are pretending that we are updating something into the database. And now the second application I'm just going to create. So this is the console application, and again a reader database. This is the name of my new application, which will be reading the data from the database. And here I need to change the project location, and I need to create it. So let me just make it full. So oh my god, it's like CS project. Let me just close it. I have to make a simple project which is in C++. It should not be in C sharp. So I need to create C++ application, which is console app, and then next here I need to write like reader db. Now create it. Okay, so just remove all these things and just using, you can use like hash include stdio.h, and then you can write like hash include windows.h, and then you can write a statement using namespace std. Okay, so this is done. Now we are just going to copy paste something from here. So this handle mutex, and apart from that, this one I need to just copy this one. So I'm just going to create it here. Oh my god, what is there? I'm not sure what the hell happens. What kind of things are behind me? Even after copying, it's not copying. I'm not sure. Leave it. So handle mutex, I have given the name mutex. So here I'm just going to create the same mutex here, and here I'm just going to wait on it. So here what will happen, that if you have run this application first, then this application will get this error code, which is error already exists. All right, so this I have already explained it to you. So now let's see. I have to create this application as the reader application. So I will just wait here. Dword dw is equal to wait for single object, and it's mutex. I'm waiting on the mutex, right? So I will be waiting on the mutex, and then how many milliseconds I need to wait? I need to wait it infinitely. Okay, so now what you need to check, you need to check whether dw is equal to wait failed, or dw double equals to wait abandoned, or dw double equals to wait timeout, which in this case may not happen because it's infinite. So it should not come, but as a practice you should write the code this way. So if any of these status codes have been returned, then you can simply write cout endl, and then you can write the wait failed. Now you need to do one thing. Since you are waiting here, once your wait is over, then you need to print a message here, endl, the db read is ready. You are ready to read from the database. Okay, so now what you will do, release mutex is mutex, and you can also close the handle. You need to close the handle basically, otherwise this will be an issue. Okay, so I'm sorry, it's done here. So close handle, it's done. So now this time what will happen, once the wait is done, you will be able to see that DB read is ready. This message will be displayed to you. Let me just run it. This is the writer application. So once the writer will be done, at the same time I just need to run the reader as well. Let me run the reader as well. So you cannot see anything for the reader. You will be able to see that there is nothing. Oh, the DB is ready. Why it is coming? Why it's coming there? The press enter when. Okay, so the DB is ready. Why this was coming? Let me just run it again. So what is this? I'm just asking for this one, M1, nothing else. I think there is no problem. This is waiting infinitely, and this is waiting on the same M1. Then why it is not working? This is something very interesting. M1 is the name. M1 is the name. No problem here. Then why the hell it is not working? This is very interesting. This is a kernel object. Why? Why it is not working? This is really interesting, man. I think, yeah, there is one error here as well. Before I go to the writing, I should wait for the single object. Wait for single object. So here I can give the name mutex handle, and then then I can just give it like infinite. Right, so this will happen like if someone is reading, then writer cannot write, and if someone is writing, the reader cannot read. So here what will happen, that first time this will create the mutex, and then it will wait for the single object, and since it has called the wait for single object function, it will simply make this mutex as non-signal, which means that the mutex is not available now for any other application, for um, any other thread which is waiting on this mutex object. I hope you got the point. So now this time we will just run it, and this time it should work fine, because this wait function is very much necessary to call. The reason is that once you call the wait function, then only the mutex kernel object becomes unavailable for others. So now I need to run the run db, and this time it will not be able to see that message, right? So I have run this, and this time you cannot see that message, because here by calling this function wait for single object, I have just made this mutex object non-signal. All right, so let me just do one thing. Here I come, and I just need to press any key. So it's done, and here what will happen, the db is ready. You can see that once that was done, then the db was ready, right? So now what I will do, I will do the reverse. I will first run the read db. Okay, so the read db is ready. After that you need to press any key, then only it will release the mutex, which means that you need to just once done, press any key, right? So I'm just adding something to stop here, so that we can see it happening. So let me just do this, and this time this wait function has been called by the reader application. So the reader is the DB is ready, but if you will go here, then the writer will not be ready. It will wait here. It is waiting because reader is not done. So since the reader is done, I am assuming that reader is done. I am pressing a key. Then in that case, you can see that the writer is started now. Press any key when the message comes, when the DB is ready. So this is the way you can work. And here you can see that we have used the main thread only. There is only one thread, main thread in this application, and the main thread in the reader application, where I have just synchronized the two threads. But if you want that within a single application, if you want to synchronize the threads, then I would suggest that you must use the critical section if you have to synchronize the threads within the single application. But if you have to synchronize the threads which are running in the various applications, in the different applications, then in that case you just need to do one thing, that you need to use the mutex or the semaphores. All right, so one thing you can do, like apart from just creating one thread, you can create number of threads here, 2 or 3 threads, and you can just synchronize the threads from one application to the other application. In the reader you can create number of threads, in the writer you can create number of threads, 2 or 3 threads. So that I leave it up to you, and you can just practice it yourself. And I hope you might have understood now that how you can use the mutex kernel object. So if you have understood these 2 or 3 previous videos along with this one, then you are ready to work on the mutexes. Okay, so have a nice day. Bye bye guys, and we will meet soon in the next video with the semaphore concepts.